We're going to start looking at solving equations, but before we start that, I want to talk about terminology just a little bit. I want to talk about the words simplify versus solve. So in directions, you'll sometimes see things say simplify the following expression or solve the following equations. So when we say simplify, we're working with expressions. For example, if I give you 2x minus 4x plus 7 minus 5x, we can't solve this because we don't have an equal sign. We don't know what this expression is equal to, but we can simplify. We can combine our like terms. So that is simplifying. And an expression is something like this. We do not have an equal sign. We don't know what the entire expression is equivalent to. In contrast, we can also solve equations. So when we see a command that says solve, we're talking about equations, and equations have equal signs. So something like x plus 7 equals 4. If we have an equal sign, we have an equation, we can solve that. Solve means to find the value of the unknown or to find the value of the variable. So real quick, another just terminology here. Let's talk about what it means for something to be a solution. So looking at this example, we have this equation, 4x plus 16 equals negative 4. We'll get to how to actually solve that algebraically in a minute, but let's talk about what it means for something to be a solution. So maybe I give you this equation and I say, all right, the solution is x equals negative 5. Verify that solution. So what that means is that our value of x is negative 5. If we want to verify this, all we have to do is plug it in for our x and see if it makes a true statement. So we have 4 times negative 5 plus 16 equals negative 4. This gives us negative 20 plus 16 equals negative 4. Negative 20 plus 16 is negative 4 equals negative 4. This is a true statement. We simplified it, we plugged it in and simplified it and got a true statement. So the solution was correct. The solution is negative 5. Maybe at the beginning, though, I didn't tell you that the solution was negative 5. Maybe I said the solution is positive 3. X equals positive 3. See if this is true or not. So if we plug it in, 4 times positive 3 plus 16 equals negative 4. 4 times 3 gives me 12. Plus 16 equals negative 4. Well, 12 plus 16 gives me 28, which is definitely not equal to negative 4. So we get an untrue statement, which means that this was not a solution. So for something to be a solution, if we plug it back into our original equation, it has to make the equation true. Okay, so let's talk about how to actually solve these. We're going to look first just at one-step equations where we only have to do one thing to solve them, one thing to isolate the variable. And I'm going to write that on here. When we are solving equations, our goal is always to isolate the variable. We want to get the letter alone. And to do that, we're going to use what are called inverse operations. So down here I wrote for you, inverse operations are opposite operations. For example, the inverse of addition is subtraction. Addition and subtraction cancel each other. They're inverses. The inverse of multiplication is division. Same thing, multiplication and division undo each other. They cancel each other. So we're going to use that information to help us isolate the variables. So starting here, we've got some addition examples, and you'll see me in a lot of these draw a line down the middle. This gets more important once we get to more complicated equations. This just helps keep our left side and our right side straight. If you don't want to, no problem. So here's our letter. There's our variable, x plus 7 equals negative 5. Well, here's what we're trying to isolate. So I want to eliminate the plus 7. The opposite of addition is subtraction. And to keep this thing equal, to keep it balanced, whatever we do to one side, we have to do to the other side. 7 minus 7 is 0. It cancels. That's what we want to happen. And we're left with just x equals negative 5 minus 7 is negative 12. So a few more one-step equation examples where we see addition in our problem. We have 4 plus x equals 8. We're trying to isolate the x, so we need to get rid of this positive 4 here. To do that, we're going to subtract 4, whatever we do to one side, do to the other side. 4 minus 4 is 0, and we end up with x equals 8 minus 4, gives us 4. On the next one, our variable's on the other side of the equation sign. That doesn't matter. Our goal is still to get that variable alone. Right now we have a plus 9 there with it, so to undo that, we're going to do the opposite. Minus 9 on both sides. This gives me 0, and I'm left with x equals 7 minus 9 is negative 2. And it does not matter which order you write your answer. Negative 2 equals x, or x equals negative 2. The last one, we have a plus 8 here with our x. I'm going to subtract 8, and I get negative 3 equals x. Okay, sometimes we may not have addition, or we may not have a positive number. Like in example 46, we have x minus 5 equals 4. This is what we're trying to isolate. Right now there's a minus 5 with it. So to eliminate that, we're going to do the inverse operation of addition. Negative 5 plus 5 gives me 0, and I'm left with x equals 9. Okay, on example 47, on some of these, like on the first one and the third one, it doesn't necessarily look like subtraction. I know we have a plus sign here, but we're adding a negative number. So that negative 6 is what we're trying to remove. We can't do minus 6 because negative 6 minus 6 does not cancel. So to get rid of that negative 6, we're going to have to add 6 to both sides. Negative 6 plus 6 cancels, and I'm left with x equals positive 4. Okay, on the middle one, here's our variable. It's being subtracted by 7, so I'm going to add 7 to both sides. I'm left with x on the right side. On the left side, negative 10 plus 7, negative 3. Okay, on that last one, we have 5 equals negative 8 plus x. The negative 8 is what we're trying to remove, so we're going to have to do plus 8 plus 8. Negative 8 plus 8 eliminates, and I'm left with 13 equals x. So that gives us some addition and subtraction examples. Now let's look at some multiplication examples. When we see a problem that looks like this, negative 5x equals 30, when we've got a number and a variable side by side, that means that they are being multiplied together. So even though there's not a multiplication sign in between there, this means negative 5 times x. Well, we said down below that the inverse of multiplication is division. So to get rid of this negative 5 being multiplied by x, we're going to divide both sides by negative 5. Again, we have to do the same thing to both sides. Negative 5 divided by negative 5 just gives me 1x, or x. That's what we're always looking for, what the value of the variable is. On the right side, 30 divided by negative 5, negative 6. Okay, a few more examples. We have 8x equals negative 24. My x is being multiplied by 8, so I'm going to divide by 8. 8 divided by 8 gives me 1x, or just x. Negative 24 divided by 8 gives me negative 3. Okay, the middle one, we have negative 4x equals negative 20. Same thing, to undo that multiplication, let's divide by negative 4. Negative 4 divided by negative 4 leaves us with just x. And a negative divided by a negative here is going to give me a positive 5. Our last one, our variable switch sides, that's okay. My x is being multiplied by 7. To undo that, we divide both sides by 7. And I'm left with x equals 6. Okay, and then our last type here is sometimes our original equation has division in it. For example, x divided by 5 equals negative 3. So we said the opposite, the inverse of division is multiplication. So if I want to undo this dividing, I'm going to multiply this side by 5, do the same thing on the other side. Multiplication and division cancel each other, they're inverses, and I'm left with x equals negative 3 times 5, or negative 15. Okay, a few more division examples. We have x divided by negative 7 equals negative 2. If we want to undo that division, multiply by -7, multiply by -7. Those two cancel, and I'm left with x equals positive 14. Second one, x divided by 8 equals 5. We want to undo this division, so we're going to use multiplication. Multiply both sides by 8. And I'm left with x equals 5 times 8, or 40. Okay, and then our last one, x divided by -4 equals 9. To undo the division, we multiply times -4. Multiplication and division cancel. And I'm left with x equals -36. So one-step equations are kind of the foundation of what we'll continue to see. We're going to continue to see more equations with more operations, but this is kind of the foundational skills that you need to know for that.